Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Syafiq bin Zakaria, number matrix AE180069, and today I will do a video presentation for final year project 2 semester 2 session 21-22. This is my title, which is Refractive Index Monitoring using Unclad Plastic Optical Fiber for Transformer Oil Application. So we move to the next slide. The first is chapter 1, which is introduction. So for introduction, transformer have a significant role in power system network, which the distribution of electrical energy from power generating station to utility end helps to regulate the voltage level and reliable and economic transmission. All is utilized in electrical equipment not just for its good in electrical insulating properties, but also because it is extremely stable at high temperatures. Refractive index is one of the parameters that needs to be measured to ensure the effectiveness of the transformer while operating. So for the problem statement, the first one is problem that leads to the transformer oil failure are breakdown voltage, temperature, moisture, acidity, pressure, refractive index, and etc. The life expectancy of the transformer oil depends on the measurement of the refractive index. And the last one is early detection of transformer oil breakdown is essential information that aids in the subsequent health condition assessment. So for the objective, there are three objectives, which is to fabricate and characterize the POF sensor using uncladding method to act as a refractive index sensor. Second is to record the intensity output spectrum for each oil sample, and the last one is to identify the linearity and sensitivity of the refractive index sensor. So for scope of work, first is 4 samples of oil with different value of refractive index were used. The center of the POF will be unclad around 1 centimeter to be used as the head of the sensor for the setup, and OceanView version 1.6.7 software will be used to capture the intensity spectrum at certain wavelength. Next, we move to chapter 2, which is literature review. So for the literature review, I have listed down all the past research about the monitoring technology of oil transformer. So this is for the monitoring technology, and next is it is for sensor technology for the oil transformer. Next, we move to chapter 3, which is research methodology. So this is the flowchart for fabricate sensor fabrication. So this is the picture. So the first step is to cut 1 meter of plastic optical fiber, as you can see here, and then we need to mark around 1 centimeter at the center of the POF to remove the jacket. And then after removing the jacket, we need to soak the unclad area of the POF into the acetone solution for around 10 seconds, and then we need to submerge it in the deionized water, and then we need to remove the remaining POF jacket using extra fine grit sandpaper. So this is are the step that is these are the step to fabricate the sensor. Next, this is the setup of the experiment. First, we use the light source. This is an oil sample that is put in the petri dish. This is the POF around 1 meter long, and this is the spectrometer and OceanView software. So this is the flowchart for the characterization of the sensor. First, we need to set up the experimental equipment and turn on the DH Mini, which is the light source over here, and then pour a sample of oil in the petri dish and cover it with a black box, and we need to analyze if the intensity reading if give a different output for each sample. If no, we need to modify the head of sensor, and then we need to repeat this step again. If the intensity give a different value of intensity output, so we can analyze and record the intensity of the spectrum using OceanView software, and then we can analyze the linearity, sensitivity, and accuracy using Microsoft Excel.
So this is the overall setup for the experiment. First, the dish mini will connect to the power supply, and then it will connect to the spectrometer. And then the POF, plastic optical fiber, that is used to detect the refractive index of the ultrasonal, will connect to the dish mini and to the spectrometer. And then the POF will be ducted into the Petri dish to make sure that it will fix. So this is the overall setup. So the dish mini will connect and duct tape to the Petri dish and connect to the spectrometer. And then the spectrometer will be connected to the laptop. So this is where the refractive index of oil measurement. So in this measurement will be use the refractometer to measure the value of the refractive index. So for the first oil sample, this is the value for refractive index, which is 1.4785. Then we need to make sure that the POF will be submerged into the oil to make sure that it will give the efficient output. Okay, then so this is the overall setup for the experiment, and the spectrometer will be connected to the laptop, and the result will be displayed in chapter 4.
So we move to chapter 4, which is result and analysis. So this is 4 sample of oil that I use in this experiment, which is sample 1, sample 2, sample 3, and sample 4. Each sample have a different value of refractive index. So this is the graph that I get from the data that we captured from using Ocean View software. So this is the intensity graph for oil sample 1, which is I set as a reference because it has the highest value of intensity, which is 8132.27. So this is also the graph for intensity, which include sample 2, 3, and sample 4. As you can see, this is the value for intensity, that the peak value for intensity using the reference wavelength at sample 1. So as you can see, the intensity at oil sample, the intensity of sample oil 1 have the highest value among the other sample. This is, and all sample have a different value of intensity due to the different value of the refractive index for each sample. So next is the linearity graph. So linearity graph, this is the linearity graph. As you can see, for the linearity graph, we have 3 different wavelength that is selected from each range. So the first one is 535 nanometer, 630 nanometer, and 680 nanometer. So each wavelength has its different linearity. So here is the graph for 535 nanometer. This is for 680 nanometer, and this is for 630 nanometer. So as you can see, for the 535 nanometer, the linearity is 0.92, which is quite high, and the sensitivity is 15,676, and then the highest sensitivity is 37,327. So we can conclude that 630 nanometer wavelength contribute to the highest sensitivity, yet came at second height in the linearity. So for graph accuracy, graph above show the accuracy of refractive index sensor for each selected wavelength, which is 535 nanometer, 630 nanometer, and 680 nanometer. So as you can see here, 630 nanometer wavelength have the highest accuracy of the sensor's performance. So we move to the next chapter, which is the last chapter, chapter 5, conclusion and recommendation. So for conclusion, all three main objectives stated in the thesis were successfully achieved. The fabrication and characterization of the sensor went well. The refractive index of PF sensor managed to give output value for the intensity. Last and foremost, the value for linearity and sensitivity at 630 nanometer is the highest, which 37,327 units and 87.25%. For the accuracy, the sensor achieved 92.23% at 630 nanometer wavelength. So for the recommendation, the first one is varying the sample of oil transformer with different value of refractive index from fresh oil until degraded oil and compare its output intensity spectrum. Second is fabricate new type of plastic optical fiber POF sensor and compare its performance from the previous sensor. Then the last one is testing the sensitivity of the sensor in real life power transformer and record its performance. So that's all from me, and thank you.